Hello and welcome back, guys. On my latest video I promised you guys that I would teach you a little bit more about object orientation. You heard that a lot, I talk about that a lot, and this is one of the backbones of how Java works. You might heard about OOP, or object oriented programming, and what exactly is that? So object oriented programming is the concept of having classes and methods and being able to communicate between them, to be able to inherit properties, to inherit methods and functionalities. So it's a little bit difficult to explain, but it's not that difficult to show. So I'm gonna show you. Let's create here a new Java class. Let's, for example, create a calculator. Okay, we have our calculator here. Remember that I talked about packages and imports on our latest video. So let's define a package for this. I'm gonna call it com.andrewsilva.math. It's a best practice to use it like your website. So unfortunately my website is not andrewsilva.com. Okay, it's andrewsilva.nl. .math. So you can put whatever you want. So when you create the package, imagine that this is going to be created in directories. So inside NL we'll have a directory called Andrew Silva, and inside Andrew Silva we'll have another directory called math. So move this. Okay, so we see here. I'm gonna create. Do you remember that we always created the public static void main, right? We're gonna create something different now. Public int sum int number 1 int number 2, and then I'm gonna use this return number 1 plus number 2. Okay, let me explain. I created a class called calculator. In this class I'm going to implement all the basic functions: sum, subtraction, division, and multiplication. This class is gonna have methods. Each method is gonna be one function that I want to. So the first one I created is a sum. So my method has a very simple logic that it gets the numbers that were received inside the parameter, it sums those two methods and returns it. So public, what does public mean? Public means that this method is visible for everybody who can access this class. This class is also public. If I change this to private, that means that everybody who's using my class, they won't be able to use this. So you might think, okay, so why? What's the point of that? Because this method can be accessed within other methods inside this. So if I create another method, blah, whatever it is, I can use sum. You see, it's here, I can access. So let's put this back as public. So public, the second word here is int. So that means that my public method is going to return something. When it doesn't return anything, it's a void. But in this case, I want to return something. I want to return an integer. And the third one is just the name of the method. As parameters, I'm just using number 1 and number 2. You can call this whatever you want, as long as they are two integers. This is the first time you see the return. Every time you have a specific return type that is not a void, you have to return something. So in this case, I'm returning number 1 plus number 2. Perfect. Now let's create another class. Java class. My main class. This class is just going to be used as a test, so we can call the methods from the calculator. Okay, I'm also going to create a package here. It's also going to be nl.andrewsilva.main, for example. Okay, so you see here on the source folder we have nl_andrewsilva, then we have main with my class and math. The main reason why you want to use a package is to make your project easier to read. So imagine that you have 1,000 classes, and that can happen in big APIs and big projects. You don't want all of the classes in there, so you want to split those classes into different packages, and each package has one specific purpose. So I want to use the calculator class inside my main class. So first of all, what I'm going to do is going to create the main method. So public stat void main, you already know. This means this is the default method. So when I have to run something in my class, this is going to be the one. How can I instantiate my calculator class? Calculator, you see, once I start typing, it already shows nl.undersilva.math. If I hit enter, you're gonna see that the import is already going to be added. So you see, nl_silva_math calculator. So calculator here, my calculator equals new calculator. So this is my class. What is an object? An object is an instance of a class. So this is my class, and I created an instance. We use the new keyword here. So new calculator is assigned to my calculator. So now if I want to access any methods inside my calculator class, I refer to it as my calculator. So if I just do this, my calculator dot sum, you see, now my method, you have all those methods, toString, notify, wait, but there's also my new method that I created here. If I add 3 and 5, okay, let's assign result equals this. Let's print this result. Let's run 8. So you see, I'm creating an instance of my calculator dot sum 3 plus 5 equals 8, and it's here. So you created a object, you instantiate that object, and you are using your own custom methods. So like we have the equals, or we have the split, or we have the add on the array list. Now you have something specific, my calculator dot sum. So let's implement the other methods. I'm pretty sure you know how to do that, right? Public int subtract int number 1 int number 2. Return number 1 minus number 2. To make my life easier, I'm just going to copy those. So we have sum, subtract, division, and multiplication. Multiplication. I don't know. Tell me in the comments. My English is bad today. Not really sure how to say that. So this changes to this to this. Yes, so we have sum, subtract, division, and multiplication. We can, of course, not assign a variable and put this directly here. Let's copy. My calculator dot subtract, my calculator dot division, and my calculator dot multiplication. So subtract, this is going to be a negative, so let's change this. 10 minus 3. Division, let's put 20 divided by 5. And multiplication, let's put a 2 and a 7, for example. So let's see if this works. Okay, 5 plus 3, 8. 10 minus 3, 7. 20 divided by 5, 4. And 2 times 7, 14. Perfect. You created your first calculator. Now let's play around with those methods. Remember that I told you about the public. Let's make the subtract as a private, for example. Oop. What happens here? We got an error. It says subtract has private access. So you won't be able to, if I try to run this, has private access. So I can't access that. So we come back here, we set as public, and now we don't have any more problems and everything works as expected. So do you see that this, in the main method, we have something called static. What does static mean? Static means that a method can be accessed without creating an instance of the class. So here we had to create a new calculator, we assign it to the myCalculator. So from now on, every method that I want to access, I'm going to use myCalculator dot the name of the method. This is very useful. We're using variables and methods inside a class that need to talk with each other. In this case, this method has nothing to do with this method and has nothing to do with this method. So I could, for example, public static int sum. So what I'm saying is this is static. You don't need a instance of this object to access this. So as you can see, we have a warning here because I'm creating the instance of the object to call that, but what does it say? Static member accessed via instance reference. As I said, a static method should not be accessed like this. You can, but that's not the way to do it. So how do we change this? Like this. So you see, I'm not using myCalculator. I'm just using calculator.sum. If we run, we have the same behavior as before. Nothing changes. For this case of classes, this kind of objects, it's always nice to have this as a static, because think about this is what we call a utils class, or like a helper class. That means it's a class that has methods, and those methods don't need any other information beside what's inside the method. So in this case, let's set everything to static, because that's more like it. And you don't even need this. So you learned about what does the public means, what does the static means. We have two other more. We have the protected and we have the default. You can also do like this. Don't need to worry about that now. Public and private are the ones that you are going to use most, but I'll come back to this later. For now, you just need to know that they exist. Now let's start playing around with this. I have a basic calculator, right? It can do the 4 basic operations. So I want to create something better, a calculator that is a advanced calculator. So I'm going to create a new class here. New class advanced calculator. So I created here my advanced calculator. As you can see, it is on the same package as the regular calculator. So this advanced calculator can calculate percentage, for example. So this is gonna be a public static float, not integer in this case, because we are working with percentages and that can have a decimal digit, right? And this is gonna be called percentage. So we receive the first number, so the idea is first you send the number that you want, and this is the percentage that you want to find out. So I'm going to return. This is going to be a little bit more complex. It's still not complex. How do I find a percentage of a number? Let's go on the very basic mathematical way to do it. So you get my number, we divide by 100, and then you multiply by the percentage. This is the easiest way to find something. Let's go back to my main class, and then I'm going to use my advanced calculator dot percentage. So I have, for example, 150, and I want to know how much is 20% of 150. Let's print this. Let's run. 30. Okay. So it is indeed 30. If you get 150, you divide by 100 and you multiply to 20, it's 30. Nice. So think about it that you go to a shop and you buy a very basic calculator. you bring it home, and then you say, hey, I need more functionality than this. This is too basic. I want to buy another one. I want to buy an advanced one. When you buy that advanced one, does it only do the advanced stuff, or does it also do the basic stuff? So in this case, the only thing that my advanced calculator can do is the percentage. What about the regular things that I created here, the sum, the subtract? I need that there, right? So we have two ways to do that. I can come here, copy all my methods, paste here, and now my advanced calculator has division and multiplication. Perfect, right? Let's say that you come to the calculator and you change the way the subtract works. You have to add some other logic in here. Then you're going to have to do it here, and then you're going to have to do it here as well. So that's not ideal. If you have 100 classes, are you going to copy and paste for all 100? No, I hope not. So one of the nicest things about object orientation is something called inheritance. When you inherit something, you are telling to the Java compiler that you want to inherit all the properties and all the methods of a specific class. So let's come back here. I only have the percentage, correct? Let's come here. By the way, not sure if I said that, but if you hold Ctrl and you click anywhere, you can go to the class. So if you click here, I go to the class. If I click on percentage, you go to the method. This is probably the number one thing that you're going to use it, like use it all the time. So Control click, and then you know. So we know we only have this. If I do a dot here, only percentage. How can I inherit all those things from my basic calculator? You go to your public class where you have your declaration of your class, and then you use the extends keyword. So extend is saying to the compiler, I want to inherit all the attributes and all the methods of one specific class. And which class is that? Is the calculator. You see that I only did this. I only added extends calculator. If we come here now, we have division, we have multiplication, we have subtract. So now, if you, for some reason you have to change something here in the subtract and change and add more logic here, you only need to do in one place, because your advanced calculator extends calculator. And although I have only one method here, I have access to all those methods here. As we can see here, division, subtraction. So another thing, private methods are never inherited. So let's make the subtract private. If I come to my main class and hit dot, you see I have division, multiply, sum, but I don't have the subtraction anymore because I marked that as private. So that's how you're going to play with the public and private. Depends on if you want that other class to inherit. Because sometimes you create a class that people might extend the class, but you have some internal methods that are only used to calculate something or to do some kind of logic, and you don't want that to be available to the other class. So you mark that as private. In this case, we're going to set it public because that's what we need. So percentage division. So now if I just copy this and I use sum, then we can run that. So 30, that's the percentage, and sum, 150 plus 20, 170. So this is a way that you can reuse your code. You always should be looking for to reuse your code and never copy and paste code, never. Okay, so let's create some more classes. I don't need this anymore, so let's delete this one. Yes. You see, when you try to delete something, and IntelliJ is smart enough to say, this class has two usages that are not safe to delete. Why? Because it knows that my main class, it's using methods from there. So if you click on view usages, it's gonna tell, you see, here and here. So two lines are using that. So it's just a nice way to tell you that, hey, you might break something, and in this case, if I delete anyway, indeed, I break things here. But it's alright, because we're not gonna need this anymore. Delete, delete, and delete this and this. So now let's talk a little bit more about interfaces. So you already know about classes and about inheritance. Another concept of object orientation is interfaces. And you can think about an interface as a guideline for your class. In an interface, you are going to describe what is mandatory in your class. So to make this example easier, let's say that we are going to create a system where we can say a few words in different languages, and you can have many different languages. I want all the classes to behave the same way. So I'm going to create a new interface, new Java class. So you see here, interface. That's what I want. And this interface is going to be called person. It's a very generic thing. Public interface person. So what I'm going, you see, we always use the public class. Now this is not a class, this is an interface. They are different things. So I'm going to describe the methods that I want all the classes to do. I want to enforce that all the classes that implements this interface has to comply. So for example, public string say hello. And then I'm going to create a public string say goodbye. Let's just keep those two to make our life easier for now. And then I'm going to create another class. This class is going to be called English person. And now here's where things change. Remember that if I want to extend something, I just type extends and my name of the class. In this case, we're going to use implements, and the implements expects an interface. In this case, person. So it already complains about something. Remember that I said that every time you create an interface, you are forcing a class to have some specific methods. So what does it compiler say? Class English person must either be declared abstract or implement abstract methods say hello. We don't have to worry about abstract right now. I'm going to get back to that in the future. But the thing is, it says, hey, you need to implement a method called say hello. So do you see IntelliJ helps us? It has a link here, implement methods. If you click here, it says, hey, those are the mandatory ones. Okay, it created for me. This is another concept about object orientation that's called override. So you are overriding the method. You don't really need this in this case. You can delete this. Let's delete it just to make it easier. But it's nice to have that. Okay, let's leave that. It's nice to have that. So when someone is reading the codes, at the first time that they look at this, they will know, okay, it's from the interface. So the implementation here is going to be based on the person. So say hello, I need to return something. I'll type hello and say goodbye. I'll say goodbye. Awesome. I'm gonna just copy and paste it to make my life easier. This is gonna to be Brazilian person. And instead of say hello, this is gonna be hola. And instead of goodbye, it's gonna be ciao. So I have my interface, and I have two classes that implements person. We have the Brazilian person and we have the English person. How can I use those classes? The way that we used in the past. So I can say this: Brazilian person, Brazilian equals new Brazilian person. Perfect. Let's create the other one. English person, English equals new English person. Let's print those things. Brazilian dot say hello, say goodbye. Now we'll do the same for the English. Let's run this and see what happens. Hola, ciao, hello, and goodbye. Perfect. Nothing new here. The thing is, all those classes, both of those classes, they implement the same person. So that means that they are an instance of that. We can even check that. So for example, if I type this, Brazilian instance of person, and then if I copy and paste this, English instance of person, true and true. So this instance of is a way that you can identify if one object is an instance of a specific class or interface in this case. Remember that I showed you this in the past. List equals new array list. Remember this? So why does this work? Because array list implements list. By the way, the control click thing that I showed you, it also works with Java classes. So if I do a control click here, you see this array list. This is the class from Java. So you see it extends abstract list and implements list. You can implement more than one interface. If this works, I'm pretty sure that this works. It does work. Let's remove this. Let's just leave the one. Let's call this a person. Let's make this generic. Say hello. Say goodbye. Let's run. Hola. Ciao. Now the thing about interfaces is exactly that you don't have to change the way your code works if you want to change a different implementation. Because think about it. Both persons say hello and say goodbye. One says in Portuguese, the other one says in English. I don't want to have to change the logic of my method to work with different languages. Because I know that the person will always say hello and say goodbye. So in order to change the behavior of my program, I just need to change the implementation. So I have the Portuguese text here, but if I change this to English person and run again, now I have hello and goodbye. You see that nothing changed here. So that's the idea of having interface, is to create a contract enforcing the classes that implements that to have a specific method. Why is that important? Because you might think, yeah, but that's a very specific example, like this is not on a real world. So imagine that you're creating a notification system, and that notification system can reach the person in different ways. It can either send an SMS message in their phone, or it can also send an email to them, for example. If you have one interface that gets the specific context and does the same logic to send that information to them, it doesn't matter what kind of implementation, if it's an SMS contact or if it's an email contact, your logic here will be the same. In the future, when we are going to create our first web application, we're going to use this a lot. So if you don't understand that now, it will get there. Try to think like this. You should always create interfaces for things that have the same behavior but with different implementations. So in this case, both of my objects have the same methods, but every method has a different implementation, because the Brazilian person will say in Portuguese, but the English person will say in English. But that doesn't mean that I have to change the way I'm printing my stuff. I just need to change the implementation, and that's it.